this is a bit sneaky. They give you 3 points, but then I should say I haven't drawn a set of axes like I did here. Okay, so you need to think about, and this is tricky, where would be a good set of axes? Okay, so have a look at the numbers you've got. 4, -5. That means go across and then down.
Yes.
-2, 1. That means go to the left and up, and then 3, 3. So I'm going to try and draw a set of axes kind of in the middle. Okay, like this.
Draw it exactly in the middle.
That looks pretty close to the middle, right?
Yeah.
Yeah, that acceptable. -5. My God.
No, there isn't a middle.
There isn't a middle for this one, I don't think. But that's close enough. Okay, so you got your 0, your y-axis, your x-axis. So again, I'm going to do this in order. 4, -5. Again, that's my x value, my y value. Okay, so when x is 4, that means go across 1, 2, 3, 4. And y equals -5 means go down 1, 2, 3, 4, 5. There he is, right there. Can you see it?
Always have to write 4 minus 5.
Okay, it's a good idea. It's a good idea. Because then you can tell the points apart, you don't get confused. B is -2, that's -1, 2. I'm going to the left, and 1. So there you go. And last one, 3, 3. I think it's a good idea, where you can.
Okay.
Like sometimes if you've got lots and lots of points flying around, maybe you want to avoid putting on so much information, but I'm just going to draw a triangle in a second. It's pretty simple. Last point, 3, 3. So 1, 2, 3, 1, 2, 3. There you go. There's C.
I think I got it wrong.
Okay, now you'll know if you got it right or not by the last step, which is it says, don't just plot the points. It says draw the triangle. Okay, so I'm going to join these guys up like so.
Oh, okay.
There's AC, there's
Did the B wrong.
AB, and there's BC. There you go. So your triangle ought to look something like that. Okay? Now, there was something a bit sneaky. I'll just get this piece of paper here because I've got 2. The next page, right? If you have a look, it starts talking about all these other things, but you might notice the 3 coordinates they give you, it's the same coordinates, right? So you can actually use the diagram you did before to help you out, okay? So here's what I'm going to do. I'm just going to have this diagram here, just off on the side, while I refer to these questions here, okay? So it is the same, it's exactly the same. In fact, it says, since the points are, right? Like it's talking about, and this is part B, following on from part A, so it's all one question. Find the coordinates of M, the midpoint of AB, and mark it in on your diagram, okay? Now, we're going to do this precisely, but in a second, before we do that, you have a look at this line, AB. You can actually, if you had a ruler, you could get it out. And you could say, well, it looks like it's about 6 centimeters long, right? I think it's going to be here. I expect it to be there. Okay? Now, that's just roughly approximating it. Let's crunch the numbers and see if it works out. Okay? So here's what I've got. What is the midpoint formula? Does anyone remember? I'll give you a clue. Starts with these big brackets.
Bracket X1.
Yes? X1?
Y1.
Whoa, before I do my X1, before I move on to my Ys, plus X2. This is the midpoint. This is the most recent one we learned. And then I divide by 2 because I'm taking the average. And then you do the same thing for the Ys. Like so. Okay? So I got my X's and Y's. Now, I'm going to label them up here. These are the 2 points I'm interested in. So I'll call that X1, Y1. And X2, Y2. Like so. Okay? So now all I need to do is process it with these particular values. So I get 4 plus -2 and -5 plus 1. Okay, you guys can help me out. 4 plus -2, what's that? That's 2 over 2, good, which is 1. Right?
And then it's minus 4.
Minus 5 plus 1. What's minus 5 plus 1? That's minus 4. You divide by 2.
Oh no, I did it right.
Gives you -2. Now, does that check out? You have a look.
I did it right.
That looks right. Look, see? 1 across and 2 down. Sure enough, it's 1, -2.
I did it. I did it. So
Okay.
I did it.
Well done. Any questions on that? Does anyone want me to clarify any steps?
Just
Okay. I'll
Alone.
try to move over.
I'm scared of taking my nails.
Okay. Calculate the gradient of
You like
BC. Okay. So I need the gradient. That's a lowercase m, right? What's the gradient
Rise over
formula?
run.
Rise over run. Very good.
Ding.
That's excellent. Now, what are the x's and y's that correspond to that?
X1. What?
Rise is about the y values, right? So I'm going to have y2 minus y1 over, and then run's about the x values, yeah? x2 minus x1, yeah?
Yes.
Okay, so let's have a look. Here are my points, right? I'll just write them over here just so I can see them right next to each other. Right? There you go. So y2 minus y1, I'm going to go 3 minus 1, like so. And then run is 3 minus, now watch out for the double negative, like so. 3 minus 1 is 2. What's the denominator? 3 minus negative 2, what's that? I think that's 5, isn't it?
Yes.
Double negative equals a positive. Now just check that out. 2/5. Does that look about right?
I'd say so.
Yeah, look, see? It goes, the rise here is 2 units, and the run, like that, is 5 units. Right? Rise over run, 2 over 5. Awesome. Okay,
That's it.
we're almost there. Calculate the distance AC. Alright, this is the long, awkward formula. Distance AC. I'll give you a clue. It's got that square root sign. What's underneath the square root?
Is it just the x2?
Yeah. It's the same as these guys, right?
Yes.
Except they're... Because from Pythagoras, they're squared, right? So, I'm going to write it like this. Squared. And the x's squared. Okay? So this comes from Pythagoras, right? So now I look at my numbers. I've got my A is 4, negative 5, and my C is 3, 3. You can see I keep on writing the coordinates every time so I know which ones I'm referring to, and I don't mix them up. It's really easy to mix them up. Okay, here's the y values. So square root of 3 minus negative 5. 3 minus negative 5, and then this one will be 3 minus 4. What's 3 minus negative 5? 3
8.
minus negative. There's a double negative, so it'll be 3 plus 5, which is 8.
See?
Well done. 8 squared. 3 minus 4 is negative 1. So when you square it, what happens? Negative 1 times negative 1.
Nothing.
The negatives cancel each other.
They're plus.
Yeah? So it's just going to become
That's it.
1.
I'm
There's
investing
a song
nothing.
about it.
I was like,
Okay.
just one.
Alright, so then, almost finished. 8 times 8. 8 squared. What's that equal to? 64. Very good. Plus 1. 64 plus 1 is 65. Is 65 a squared number? No. No, it's not. Did they ask you to approximate?
No.
No. So you just say units. Done. Okay? Which would be like 8.1 or something. I don't know, 8.2, something like that. But that's finished. Yeah, that's right. Exactly right. You don't need it. Okay, last step. Determine the rule or equation of the line AB. Now let me just put it on the picture again. AB. That's this line here, right? This line here. Okay. So how are we going to do it? This is my many lines. Okay. We need 2 pieces. We need 2 pieces. I need a y-intercept. That's this one here, and I need a gradient. A y-intercept and a gradient. So can you read off? Like I've done it. 1 grid square is 1 unit. So what would that value be? It's just 1 below the origin, yeah? So it should be negative 1. Very good. Okay. So that's my y-intercept. I'll just tuck that away. Now what's the gradient? This is a bit trickier. What's the gradient? We work out gradient by rise over run, yeah? Rise over run. Now I go from left to right. So what's the rise?
3.5.
It's actually going down, isn't it? Can you see that?
Negative 2.
So for example, the rise, you might say, okay, how about negative 2? From here to here. That's negative 2, right? So the run that corresponds to that is 2, right? So it's rise is negative 2 and run is 2. Can you see that? Okay. So therefore, let me come back to here. You already told me that the y-intercept is equal to negative 1. And the gradient is rise over run, which you told me was negative 2 over 2. What's that simplify to? That's negative 1, right? Okay, so I need to put these two together. This guy and this guy. It's nice and convenient that they're the same. Okay, I'm going to put them into this form. Do you recognize this? Right? There's an m and a b. Which one's which?
The gradient.
That's the gradient, and that's the y-intercept. In this case, because the numbers are actually the same, doesn't matter, but usually they'll be different. So you'd put the gradient here and the y-intercept here. In this case, I get negative x minus 1. And that's the equation.